Is my screen visible?
Just a sec, not yet. Yes, it is visible. So let's start.
Okay, so welcome everyone. My name is Arpan Adlakia. I'm a final year undergrad from computer technology. So let's start.
Let's check again once what we'll be covering in these slides. Also, these slides contain a lot of resources which will be shared later, so don't worry about it. As I said, what is Linux we will cover. Next slide. Where is Linux used? There is so many use cases of it, and you will be blown about to see it. What is a kernel? Because this is one of the most confusing fact about Linux, that Linux is an OS or Linux is a kernel. That's why we'll cover it a bit, like what is kernel, why Linux is a kernel, not a complete system, and when we can call Linux as an operating system. Also, we will cover about what's the differences between Windows and Linux, because most of us right now use Windows, and a few of you all have ever used Linux. So we'll see what are the differences. And of course, the main motive of this session: lots of hands-on, lots of exercises, go through with commands and see and getting familiar with the Linux UI and CLI as well. Next slide.
So let's look at what is Linux. So many of you may have been using Windows and Mac OS. So just like that, Linux is an operating system. So basically an operating system is just a kind of software that allows us to use our computer. As simple as that. But when we say that Linux is an operating system, we are not technically correct about it, because Linux in itself is just a kernel. So you may ask, what is a kernel? A kernel is basically a low-level operating system, which kind of interacts with the hardware of your computer. So this kind of thing, like a kernel in itself, is pretty useless because you cannot directly interact with the kernel. So we need some kind of an abstraction layer that would interact with the kernel, which in turn would interact with the hardware. So for that, we use the GNU Linux. So some of you may have heard about it. The GNU Linux is made by the GNU Free Software Foundation. It is basically a movement to make free and libre software that is not closed source and is free to modify and reuse. So GNU provides some basic software collection along with the Linux kernel. So basically, the last thing is the Linux distribution. So many of you may have heard of Ubuntu or Debian or Arch or Fedora for that matter. So these are all called Linux distributions. They are called distributions because they feature the Linux kernel, the whole software collection provided by the GNU, and the desktop environment and additional software that you need in daily life. So we might say that a Linux distribution is a complete OS and not just the Linux. So you might wonder, where is Linux used? Because you might think that Windows is the most popular operating system. Over 70% of market share is of Windows, but Windows is only limited to the personal user space or the personal computers that are in the world. But when you might look around, the very platform that you are using, like the Google Meet platform or the Google presentation platform, it is being hosted on a Linux server. So 99% of the world's top supercomputers run Linux. Most of the Android devices are based on Linux. Then all the stock exchanges, like most of the stock exchanges around the world are on Linux. So Linux has been to space. It has achieved some great limits. The Curiosity rover had Linux on board. Then the SpaceX launched their Falcon 9, the reusable rocket, in I guess in June 2020. So that also used Linux with the Dragon sub module, I would say. Then it has also been to 32 different space missions. Linux is also used in traffic control, the airport transmission, then also the rail communication around the world. Linux has been big in Hollywood because most of the servers that are used for producing and editing films have been used in Linux. Titanic was the first feature film to be produced on Linux servers. So Linux also has its use in the IBM's Watson, which is the smart assistant of IBM. Then the God particle that was founded by the CERN's lab was also using Linux. And all the major top companies that you have heard of, like Google, Amazon, Apple, Microsoft, they all use Linux to power their services. Linux has also been under the ocean and has been providing or has been like detecting anomalies and different formations that happen inside the ocean and on the seabed. Let's look at what's the difference between Linux and Windows. Over to Anmol.
Thank you, Arpan. So we'll see. First of all, we will cover about Windows because that's what we are already familiar about. Let's bring it on. Windows is closed source. Windows is closed source. You cannot see the source code. You cannot see how things are being happening under the hood. And as a developer or as a geek person, you already want to explore how things work, and Windows doesn't allow it. So that's one of the cons for us. It is paid, and I think it should be written. It is expensive because it's really as for just a piece of software of 2 GB in size. I agree that's a whole complex piece of thing, but costing it for 10,000 and just for the home version, Windows Home, and if you go for Windows Pro, that is professional, you need to spend like around 14, 15, 16,000. That's not what I would think as a geek I would prefer. It's relatively less secure because, of course, Windows users are more generally targeted by criminal-minded hackers. I'm talking about criminal-minded because hackers is not a bad term. Crime is what those people go wrong when they do it. And there is no transparency. Yes, you cannot see. If you, for example, if you open up Windows Explorer, you will have no idea what that Explorer is doing. Or if you open a open a window of Microsoft Edge, what data is being manipulated behind the scenes, you have no idea about it. It's just like a light box. Something goes in, something goes out. What's happening inside, you have no idea about. Right? Yeah. Cool. Privacy not found. Yes, but there are many things built inside of system. For example, if you check up the Windows timeline, it is tracking whatever apps you are opening, how frequently you use them, and it's collecting that data to understand how what is the behavior of the user. And even if you want that they shall not be observing this, there is just almost no options. They have ways to collect data. Even if you say that don't collect my data, they have something to collect it. You cannot contribute directly apart from reporting bugs. Yes, in case of those who are familiar with Git and GitHub, you can actually go to a GitHub repos, contribute changes to it that makes it better, or solves some bugs that are already there and you have spotted them. But in case of Windows, the best thing you can do is report them that such bug exists and you have suffered it, and wait for them to release the patch for it in the next upcoming update. It is available only in binary. You can just directly use it. That's all. There is nothing that you can do with that piece of software, and that's Windows how we know it. And we often call it BSOD. Anybody know what is BSOD? Quickly, 5 seconds. Type in the chat box. Okay, looks like nobody knows about it. So BSOD stands for blue screen of death. Okay, Aditya says no. Okay, so BSOD stands for blue screen of death. Why we call it? If you know how Windows updates, you might remember that it comes a blue screen, completely taking on the whole screen space. You cannot do anything while it's updating, and you have no idea when it will finish. You have no idea when it downloaded the updates. It just tells you, I have downloaded the updates, I want to update, let me update. That's all. It's all about Windows itself. But here's the things that changes. Now come to Linux. Everything changes. Everything changes.
I would like to add a point about BSOD. It's not just the update screen, but if you have experience, if like anything goes wrong during the updates and you reboot the PC and there is like this sad emoji that comes in, a big sad emoji saying that there was an error updating the system and your system won't boot. That's actually the blue screen of death. And we have experienced it many, many times.
Developers experience it almost every 2 or 3 months if they use Windows.
Yeah. And
let's come to the part Linux. First, biggest part that we all love about, it's open source. Completely open source. Every driver, every module, even the whole kernel itself, everything is open source. You can go there, clone the repo, make some changes, customize your own system, and you have it. It's completely freedom. free as for freedom. That's the main concept about open source, and that is what Linux follows hardly. At least follows in die-hard sense. Of course, it's open source, it's free. You don't have to pay any piece of money and nothing. You can, of course, in order to support them, you can go and donate them some wealth to keep the things running. And what happens when a piece of software is open source? You have more contributors, you have more people to help us build, help us make it better, and that's why it is relatively more secure. Another thing, it has frequent updates, patches that are too frequent, monthly, weekly. You get them, and it's up to you want to install them or not. It's relatively transparent because you have the source code. You know what the piece of software or driver or any utility that you will use, what it is doing inside the hood. And next step, it respects privacy. There is nothing called as bloatware and all stuff that will keep on collecting your data to make money out of it. They're just not collecting any data because it's open. There is just the code that is needed for the work to be done. Next piece. Contribute. Yes, this is one of the most beloved part. You can actually make Linux better for the whole world. Gives you opportunity to create, make your dent in the world, as said by Steve Jobs. You can go there, read the documentation, understand how things work. If you think you can make it better, make a pull request, make a fork, do the changes, drop a pull request, and talk to them to make it joined into the Linux system. Next slide. It's available in source code and binary. As I said, it's available on GitHub, so that implies it has a source code open, and that's what open source means. And here you can see what's the difference between Linux and Windows. Windows, working on updates, I don't care what you want to do, I will update and only then you can use me. Linux, there is kernel update that is important, but if you don't want, I will not install it. The complete freedom and complete control is in the hands of the user and not the system. Okay, next slide.
So I was talking about what is GUI and what is CLI. So GUI, you have already been using GUI, that is Windows, where you have to work around with your mouse. Like everything you do is with your mouse and hardly anything with the keyboard. Whereas in CLI, it is called command line interface, and it uses only keyboard. There is no mouse interaction. It's just the keyboard, and all the commands are typed from the keyboard. So in Windows, you may have seen like command prompt, and in recent versions there is PowerShell, and in Linux there is terminal. So the main difference between terminal and the command prompt is that command prompt was an afterthought, because originally the Windows didn't plan to integrate the command prompt into the Windows quite severely, whereas the terminal was the first thing that Linux got it. The GUI was developed later, but the terminal was first the sole thing that was available in Linux. So let's look at what is a terminal. A terminal is used to give commands to the OS. So just like in command prompt, you type something, you type command, and the Windows executes it. Similar to that, terminal also just takes in commands from you and gives it to the OS to execute. So it allows us to interact with the shell. So you may ask, what is a shell? A shell provides basically an environment. So it provides like an interpreter and some environment to allow the OS to recognize what kind of command you have entered, what are the things that you want to do with that command. So shell allows us to interpret all the commands and then execute it. So there are different kinds of shells that are bash, KSH, TCSH, and ZSH, whereas bash is the most common and almost the default shell that comes on most of the operating systems. So we'll look at bash. Gentle introduction, over to Anmol.
Yes, so this bash is born against shell. It is called because there was something called as SH, born shell, and we as developers improved it. I did some features, I did some shortcuts, I did some workarounds to make things more productively faster. So there came born against shell, with that we call as bash. And as said by Arpan, Bash is generally the most default shell that you get in a Linux distro. There are some other shells, ZSH. This one looks amazingly beautiful when customized nicely, and you might change your thoughts on CLI after you see a good ZSH customized CLI. And let's proceed further and see what we have in the back for today. This is not what it's not about the shell, but it's about commands. So that's why we'll focus on that.
Yeah, so let's look at an overview of what kind of commands we'll be seeing today. So these are some things that you would normally do as a user, even if you are using Windows, you kind of navigate through the file system and do some file manipulation, that create, remove, or modify some files. Then use some system commands to view system information or network information. So these are some basic things that we do in Windows that we'll see how to do in Linux. This searching, piping, and redirection is quite a good thing that is available in Linux. It is very powerful when you are working in a large project. We'll also see how to look at hardware info, like you're from electronics. You mostly use devices that you plug and play. So you need to look at what kind of devices are attached and what are their device IDs, etc. Lastly, we'll look at the users and permissions. This is a concept in Linux which allows or the control over what kind of user has access to what kind of files and folders. And then we'll look at how to install some packages and some other utilities. So let's see our first commands. So PWD stands for print working directory. So most of the commands in Linux are pretty self-explanatory. Print working directory will show you what current directory you are in. So if you are using Windows, you often call them folders. So basically in Linux, the folders are called directories. They are one and the same thing. So print working directory shows the current directory that you are in when you open up a terminal. The next command is CD. CD is like the most basic command that you will use when you are using terminal. It stands for change directory. Change directory means you want to go from one directory to another directory, as simple as that. Next is LS, that stands for list. List is used to like list down the contents inside the directory. So as I said, the commands are pretty self-explanatory. So we'll see all how this works after this slide is over. So next are flags. So this might be, you might not be familiar if you're using Windows. So flags are something that you can provide with a command to provide some additional options to the command. Like if I will give you a demonstration of flags when we see a demo of this commands. So tree is a command that just visualizes a directory in a tree structure. So it shows you a beautiful structure in which how your files and folders are arranged, that we'll see. Then clear reset, this will just clear your terminal if it's like filled in with crap. You want to clear it out and want a clean terminal, you can just type in clear, hit enter, everything will be cleaned out. The man command is very useful. It stands for manual. So manual command, it just shows the complete information about a command. So say if you see a new command and you want to know more about it, so you can just type man and the command name and it will give you everything about the command that exists. And lastly is the sudo command. So you may have seen this command if you have seen some online memes, Linux memes and things like that. So sudo stands for super user do. Super user is basically admin, as in Windows, admin privilege. So it says that do this thing as an admin. So it allows us to execute something with admin privileges. You may see this run as admin in Windows. So it's just like that. So let's see some examples of these commands. So is the ID visible? Anmol?
Yes, it's visible.
Okay. So if you like open up an actual Linux terminal, this is a kind of structure that you will get. This symbol here that can you see my cursor?
Yes, we can see it.
Yeah, so this that the tilde symbol I've just printed, it signifies the home directory. That is the directory that opens up by default in a terminal.
Sorry to interrupt. Arpan, can you please increase the font size?
Yeah, just
Yeah, perfectly fine. Cool.
yeah. So let's see some commands. Also, this the dollar sign that you see here signifies that you are a user and currently you do not have any admin privileges like admin permissions, etc. If you see kind of a hash command instead of the dollar sign, that means that you are a root user. That is the admin. Okay. So let's use the pwd command. It's just pwd, hit enter. It shows you the current directory that you are in. So it is the directory structure home Ubuntu. In Windows, you have like backslashes. So it's like if this was in Windows, it would be like backslash C backslash home and something like that. So in Linux, there are forward slashes. So forward slash home forward slash Ubuntu. This is your current working directory. Now we can ls to see what all things we have in the directory. So we want to list. So there are just two directories. One is called parent, one is called React. Now, how you may wonder how you differentiate between a directory and a file. So if something has a slash in front of it, then it's a directory, and if something doesn't have a slash, then it's a file. So it normally shows the extension of the file also. So if we just want to go to the React directory, so you just say cd, that is change directory, to the directory name, that is React, and it would bring us to the React directory. We can now ls and see. Now here you can see that there are some directories like fixtures that has a slash in front of it, then scripts, and these are all files that has some extensions in front of them. So after that, now if we have to visualize how this directory is organized, so we can just use tree, and you can see that it is a very big directory. Let's just go back to the parent directory that I created. So you see the clear command that clears out the screen if it is cluttered. So now let's tree, and you can see like how the parent directory is organized. So you have like the child 1 of parent, child 2 of parent, then child 3, child 4, and then there are subchilds of this directory. So these are all directory names that I've created. If you just ls, you can see the directory names. So I was going to tell you about flags that we use. So flags are basically used to tell to give extra instructions to a command. So for example, if you want to view who are the owners of these directories, the child 1, child 2, child 3, etc. So you would say ls -a. -a means that you want to view all the information that is available to about the directories, and would say L. -al stands for show all the directories, show the detailed view and all the information that is available. So if we hit enter, you can see that all the directories are owned by the user Ubuntu and the group Ubuntu. Okay, and you can here also see that these signifies the permissions. We'll get into permissions in the later part of our today's session, but just for now you can just see the directory structure and all that. So let's move to the next slide, that is file manipulation. This is the basic requirement. If you are using an OS, you need to create some files, you need to modify it, you need to remove it. So how can we do that? So the first thing is, if you want to run a file, so in Windows you may go to the file name, then double click it and it would just start running. So in Linux, there is like just go to the directory of that file, hit / and the file name, and it would execute it. As simple as that. Apart from that, if you want to make a new folder, there is this command called mkdir. which stands for make directory. So make directory is used to create a directory, as it explains itself. Then there is a move command, that is mv. It is used to move files from one place to another, or it can be also used to rename the file in the same place. Then to remove files, there is rm, remove. We will see all these commands at the demo of all these commands. So the next is touch. Touch is used to just create an empty file. So you might just say touch and a file name. It would create an empty file. That's it. Then there is a cp command. This is a very useful command which is used to copy files from one location to another location. So it can be used to copy files as well as directories. And then there is an echo command. Echo just prints out what you give input to it. So if you say echo hello, it will print out hello on the command line. And if you want to display the contents of a file, then you have these commands that we'll look into: cat, head, and tail. And there is this star and unzip. If you download like a zipped file, you want to unzip it, so you can use this star and unzip files to work with. So let's just see a quick demo of these. So now if I go back, yeah, one thing I forgot about cd is that dot, if you say cd dot, it represents, a single dot represents your current directory. Okay, if you put a double dot, the double dot represents the parent directory of the current directory. So if you are in parent and you say cd dot dot, so it might it would say change directory to the parent directory of the current directory. So it would go back to the parent directory. And if you are in like React and some kind of packages, and like you want to go to the home directory, you would just say cd, and to the tilde that we looked at in the start, it represents the home location of your current terminal. So it would just go back to the home directory. So yes, we have to see the file manipulation. So mkdir, we can just create a directory mkdir and a directory name, that is test. So now here is the point where the Linux terminal shines as compared to the command prompt and PowerShell. So let's say I would just remove that test file, test directory. So okay, yeah, so it's removed. So now if you say that you want to create like this kind of structure, yeah, so you want to create this kind of structure, like parent, there is a parent folder, then there is 4 childs, and there are 2 subchilds in the child2 and child3 directories. Now typically if you are a Windows user, you would just right click, go to a new folder, give a name to that folder, click enter, then go inside that folder and just follow the same process for all the folders. So it feels time consuming, like. So we can do this in just one line with the mkdir command. So if we want to create a new directory with such structure, we would say mkdir. We would give it a flag called -p. -p stands for create all the parents. Like if you are creating a subdirectories, then it would say that create their parents also. Okay, so we would say the main directory name is test. Now we want to create some kind of directories inside it. So we would give it curly braces, and inside curly braces we can just specify the directory names like new1, new2, new3. So this will create a test directory and 3 subdirectories, that is new1, new2, new3. Now you would want to create some subdirectories of new2. So you would say new2, again curly braces, and then sub new1, sub new2. So if we now hit enter and we tree the test directory, so you see it created a new 1 folder, it created a new 2 and the 2 sub directories that we specified here, and it created a new 3 folder. So this quite comes in handy when you are working with projects. You want to create new project structure. Instead of doing like clicking and all that stuff in Windows, you can just provide one command and it will create the whole directory structure for you. So that's pretty handy. Next comes like the move command. So we can move suppose we want to move the new one folder to new 4 folder. So we would say move test new 1 to test new 4. So basically what we are doing is we are moving the new 1 folder to the new 4 folder. So if we like tree test, so you see the new one that existed here is now renamed to new 4. So it moved the new 1 folder to new 4. Now if we want to copy the new 4 folder, test new 4 to test new 5. So it would just, okay, it's directory. So yeah, this is an important thing. If you are moving or copying directories, you want to specify this -r flag. -r specifies recursive, so it would always it would copy all the files that exist in that directory accordingly. If we see that and then tree test, so you see the new 5 directory has been created. So these are some basic commands that allows you to manipulate files. You can of course remove folders like rm test and new 5, and of course since it's a directory we have to specify the -r flag. You would say yes and it's removed. As simple as that. So let's move on. So these are some system commands. On Windows, usually you go to this PC, then right click on it and go to the properties to view the properties of your computer, like what version of OS you are using, what kind of CPU you are using, what amount of RAM you have in your computer. So you can do all this with these system commands. So if we just say uname, uname stands for just display the basic system information such as the OS, the kernel, the architecture, that is it's 64-bit or 32-bit, and things like that. The host name gives you the system name, that is in Windows it's Windows or the PC name that you have specified. In Linux it's the machine name that we specify while installation. Then who am I, as it self-explains it, that it shows your username, that who you are logged in as. Then these are some extra commands like date, calendar. Date displays the date of the current date of the system. Calendar displays the current day and month. And there is uptime. Uptime is just shows you how long the computer has been running after you booted it. So let's just look at some of these examples. So if we type in uname A, so look, the first thing that it tells is the OS that it's running. So it's the Linux OS. The next thing is the username. So it is an ID, that's why it's such a long username. Usually it will be the one that you provide during the installation. So it tells us the kernel version, that is this, the architecture, that is this, the x86-64 one, and then the date and all that stuff. So pretty much uname gives everything that is like provided by other commands. If you say who am I, it says Ubuntu, because your current username is Ubuntu. You are logged in as Ubuntu. Pretty basic stuff. Yeah, so next comes some of the network commands. At this point, I would like to say that if you are just trying to note down all these things, please just sit back and watch and try to understand what is happening, because we'll be sharing all these slides and cheat sheets of commands. So don't worry about taking notes. You'll all get all the contents and resources.
Also, there is something to add. We might get a bit short on time, so let's cover the next upcoming ones a bit faster and get to the hands-on part. Okay?
Yeah. So in network command, like these are the commands that mostly people use if they are using Linux. So the IP commands, IP you have heard of, it displays the internet protocol address that your computer has been assigned. So it can be used to identify what IP address is assigned to your computer if you are a big organization network. Then there is a ping command that is used to check whether a website or a host is online, that it is connected to the internet or not. So it just sends a kind of ping, like when we send on social media ping to someone to just check on them. So it sends kind of a ping message to the host. Then there is, I would skip to the wget command. Oops. Yeah. I would skip to the wget command, which is a very powerful utility to download files from an online service. So in Windows, usually you do like click on a download button, then it starts a download in your browser. Instead, you can just copy the link of that download, hit it with wget, and it would just download it very fast, like according to the speed of your internet. So it's quite powerful and feature rich. So let's see some of this. So if I type IPA, oops, okay, it's running, I think, an older version. So it might, yeah. So in current Linux versions, the IF config is deprecated. It is no longer a part of the whole network stack, but it was used in older versions. So maybe this ID is a bit old, but in current versions, you would use the IPA command. So yeah, it shows you the 80, that is your Ethernet card in your computer, and the IP address. So this is the local IP address that is assigned to your computer. Apart from that, you can just ping like Google. Okay, ping is not here. Okay, no problem. Ping is usually installed when you install Linux on your system. Since this is an ID, I don't know. Like some of the commands may not be available. Okay, so next we come to searching, piping, and redirection. It is very important to learn these stuff as it helps a lot when you're managing big projects. So in Windows, like if you want to search for something, so the typical Windows user would go into that directory, hit Control F, and then type in the name of the thing that he wants to search, and Windows will search it through folders and files. But if you want to search for the contents of the files, that's not quite easily possible on Windows. But on Linux, using the grep utility, that is the grep, it can simply look into the files and folders and grab the content that you want to search. So grep is read as apply the print command on all lines matching the given regular expression. So this might seem a lot to you, but when you see a demo, you will just get what kind of output the command gives. Then there are locate and find, which are used to find files. Find is like quite aggressive and feature-rich tool to find or locate any files. Then there are pipe and redirections. So you may be first time hearing about this pipe. So a pipe is something like in real life, what does a pipe does is that it takes some kind of input from one end and just passes the input from the other end to the like environment on the other end. So similar is the pipe on Linux. So it just takes the output of command on the left hand side and passes it as an input to the command on right hand side. So you'll see a basic example of that also. Then there are redirections. These are very important when you're working on the terminal. Basically, they are like these greater than signs, less than signs. So we will look into them in the demo. So just look at the demo of these things. So for example, if I'm in the React directory, okay. So now I want to search what kind of files contain the word hello. Okay, so I want to search this word hello in all the files that are contained in the React folder. So what I'll do is I will say grep I will call the utility. I would say search this word right here, and I would just say dot. And as I said earlier, dot stands for the current directory. So it would just go on searching for this hello world into the current directory. If I hit enter, okay, we will have to specify the R flag for recursive since it's a directory. And as you see, there are a lot of matches. So what grep has done is it just went into the directory, opened up all the files, searched for the word hello. If there was a match, it just printed out to the terminal. It comes quite handy when you're working in a large file system or a large project. You want to search for something, you can just grep it and it will give it to you. The next is the pipe. So we can just like use the echo command that was earlier. So you would say hello world. Then I would just, okay, it's not supporting multi-line. Echo generally supports multi-line objects, but okay. Hello world, and we would just pass the output of echo to grep, and would say find hello in the line. So see, it takes on the input from the echo command. It passes it as it passes the output of echo command as an input to grep, and then grep performs the find or the matching function on the input that is given. So it has highlighted the hello string here. That is called piping. And redirection. So redirection is quite interesting. If you want to like do echo hello world. Now, instead of passing the output of this echo command to another command, we want to save it to a file. So what we'll do is we will specify this kind of a greater than sign. Greater than sign means just take the output of the previous command and output it to a file. So we would just say file.text. So there, if we ls it, you see there is a file.text here. So if we just cat out the file.text, it would say hello world, right? So cat is used to like view the contents of a file. So it is just the basic utility. If you want to view what is inside a file, you can just cat file name. Then let's yeah, I would also just show you the append thing. So if you specify a single greater than sign, it would just overwrite the file.text. But if you want to append something, like if you do not want to overwrite it, if you want to append it to the end of the file, you would specify 2 greater than signs. So now if we cat, you would see it has not overwritten the original hello world and just appended the next hello world below it. So these are some redirection operations. They come in quite handy when you start working on projects and stuff. Then hardware. Hardware is very important when you are working with external devices. So if you are working with like plug and play USB devices or flash drives or external hard disks, these quite come in handy to get information about what kind of device you have connected. So we would just cover the important ones, that is the LSBLK. LSBLK stands for list blocks. It would list the block device information about the hard disk. So there are in Windows, if you have ever opened the disk management utility in Windows, then it shows you the partitions and all that stuff about a disk. So similar to that, LSBLK will show you the partitions that exist in a disk. Then there is LSUSB. Similar to LSBLK, it just lists out all the USB devices that are attached to the system. I don't think that we'll be able to demonstrate this on the IDE since it's like hosted on another server. But if you have installed Linux on your system, that you will be able to do that. Then there are this important commands, that is mount and umount. So mount just helps to mount a plug and play device to a specific directory. So suppose you have attached a pen drive that you want to access. So you would just you list the pen drive by LSUSB and then mount that pen drive over to some directory. And umount just unmounts the mounted devices that you mount with this command. Unfortunately, we will not be able to demonstrate it since it's an online IDE. So, but you can explore it after you install Linux in VM or your system. So, users and permissions. This is a concept that is different from Windows. In Windows, you have like two kinds of users. One is the normal user, and the other is the admin. So a normal user doesn't have permissions to uh, perform administrative actions. You need to enter the administrative password and take permission of them to perform such commands. Similar to that, there are different kinds of users in Linux, and if you want to perform some action using the administrative privilege, you use the sudo keyword that we looked at earlier. So some basic stuff, that is ID. It displays the users active users info. So if you are logged in as your normal user, it would just display the user ID and the username and the basic stuff like that. Then there are permissions. So I would just share the ID. So we are just listing the detailed information about the file.txt file that we created earlier. So here we can see this thing that looks like some dashes, some words, some characters, etc. These are the permissions of these files. So basically the first character specifies whether the file is a directory or a normal file. So here, since file.txt is a normal file, it is blank. If it was a directory, then there would have been a D at that place. The next three group, that is these, specify that the permissions of the user, that is the current user that is logged in. So there are just three kinds of permission, that is read, write, and execute. Basic kind of permission. If you want to read a file, then you need to have a read permission. If you want to write to a file, you need to have the W or the write permission. And to execute it, you have to have the X, that is execute permission. So currently you can see that the user has only read write permission. The next three group is for a concept called group in Linux, but we'll not dwell into that because it's quite an in-depth topic if we cover it. So you can explore what is users, what is groups, and what is the difference between them. Then the last three characters shows that anyone apart from the user and the group. So these comes in the others category. So whatever permissions will be specified here will be given to the people other than the user and the group. Okay. Chmod is a very important command that you will be using frequently if you are making executable files. So chmod stands for change mode. It is used to change the permissions of a file. So if we come here, now say we want to give execute permission to the above file, that is file.txt. So we would say chmod. Then since we want to give the permission, we would say plus. If we want to take the permission from them, we would say minus. So we would say plus. Now what kind of permission we want to give? That is execute. So we would say X. If you want to give write permission, we would say W. If you want to give read, we would say R. So it's say X and then file.txt. Now if we just lsal, you can see the X has been updated. That means the file.txt has an execute permission. Lastly, this is some basic packages and other utility stuff that you may require. So most of the popular system that is the Debian base, that is Ubuntu, is used by many people as it is beginner friendly. So Ubuntu comes with this package manager, that is apt-get. It is just like you would specify the name of that package manager and the name of the software that you want to install. So it's just that apt-get and the name of a package, just simple as that. Then there are some other utilities that are important. So there is the history command that shows the history of commands that you have entered in your terminal. Then there is this alias command that is quite you can say, if there is a command that is quite long to type, you can give it a short name by using the alias command. So you would just say alias, then a short name to that command, and specify what the command is. So it comes in pretty handy. Then there is htop, neofetch. These are just the system monitors, like the task manager in Windows. Htop is a system monitor in Linux. So the next thing is Vim.
Yes, before moving on to Vim, there is someone, Dipesh Verma has raised hands. I think there is some question. Please
Yeah,
say
Dipesh.
what. Mr. Dipesh Verma, you there?
You can type in the chat box.
Or simply unmute and say it. We are waiting for a few seconds, like 5 seconds.
Okay, no problem.
Okay. For sure. Okay. Please raise hands or type in the chat box if you need. We'll be welcoming questions as well, in case they seem that much worried about. Okay, so
Yeah.
it's time to Vim, and you may or may not know that you can actually edit text on inside files right in the CLI. You don't need to leave the CLI at all. And so let's start with it. Next slide. Okay, so how do you create, how do you manage files, how do you manage directories? You have already seen it as said by Arpan. And now we'll be editing data inside those files. How do you edit a file? Like Vim is an editor, it is a text editor. So how do you open a file inside Vim? This is the command, Vim file name. Given that you are in the same directory as the file and you're running this command from there. The example is already there, vim hello.cpp, where I'm in a directory where there is a file hello.cpp that I want to edit, and it will open up the editor. To start editing, we will need to press I. This is insert mode, and to exit the insert mode, you can press the escape key to enter other commands if you want to use. There are a lot of commands and features in Vim, but we'll skim through the most basic ones that we will need every now and then. Next slide. So here is this example file. If you see on the left, there is a simple file. Once you hit vim hello.cpp, this is what comes up above. There is file name, then there is contents of file. Those blue tildes are just nothing but empty space, you can say. And there is, in the lower side, we have the working, you can say the file location and the current working directory, and what line you are there, like that you are on 8th line and 78th character, that is also shown. Now if I want to edit something, I want to make changes, like for example remove some characters or add some characters, I need to press I, and when I press I, there is this thing called insert that has came. You can see in the lower left of the right image. I have highlighted it with the right arrow. And this is the moment where you can make changes to the file, add some data, you can change the code. For example, if I want to make it like hello world and hello use or something, I can do it. And once I need to go back to the, you can say what it is, view mode, view file mode, and where you can run commands for like save, copy and all stuff. There are others which we will not cover in this session for now. So you can go with, just press the escape key, usually found on the upper left of the keyboard. Next slide. So we will just, this is the final one with the Vim. After that, we will do a clear hands-on. I made this using CPP. Now I will do the same for Python so that you can get familiar with that as well. Or maybe you can stick to CPP because there is something called as a.out that you might worry around a lot because I
can show them a demo if you want.
I'll do. Don't worry.
Okay.
I'll cover the demo.
Should I stop
okay,
presenting?
Yes. Share screen. Okay, you can do that. Let me cover the slide. Exit Vim with and without save. While in view mode, that is out of insert mode, that insert text is not there. While in that mode, you can just press colon key and then Q to quit Vim if you don't want to save your changes. If you want to save your changes, you can go with the colon and W, which means for write the file, means exactly save the changes onto the file. And if you want to do both of these things in one shot, you can do colon WQ. like colon, run a command, W, save the changes, Q, quit the file, quit Vim editor. So we can do this in one go. Okay, now Arpan, please do a quick walkthrough of the same thing. Now this time you can create the hello.cpp file, I guess.
Yeah. So just we can use, I hope Vim is installed. Yes, Vim is installed. So we can just create a file by using Vim and the file name. So I'll just say hello.cpp. So it will just open up a hello.cpp for viewing. So basically when you open up a file in Vim, it initially opens up as a view only mode so that you don't accidentally make any changes to the file. If you want to make changes, you just hit the I button, that is the insert key. So it just shows this insert at the bottom. That means that you are in the insert mode now. So you just type a small program. Vim also features like highlighting the brackets and all that stuff. So it's pretty powerful. There are also extensions for Vim which you can install, like autocomplete and all that stuff. So it's pretty extensible. Or I would say cout. And return 0. So I think this is it, a small program. Now, okay, so we were in the insert mode. Now we have finished modifying the file. Now we want to just save the file and quit the Vim editor. So we would first hit the escape key. So you can see the insert from below is gone. It's now in view only mode. We cannot enter anything. Okay, I can insert again. Yeah. So it is not allowed to edit until you hit the I key again. So now we could just type a colon to give it a command and would say first save the file. So it would say first W, that is write the file, and then we would say Q to quit the editor. If you say QW, it would just try to quit the Vim editor without first saving the file. So the order matters. So we would say just WQ. So the hello.cpp has been created. Now to compile the file, usually in Windows you do this stuff in IDE, but on Linux all the tools that are used to compile C or CPP files are already available while you install the OS. So you could just say G++ for CPP, hello.cpp. So it has compiled. You can see here in the left side that .a.out file has been generated. Now to run the file, as we have seen earlier, we would say ./a.out. I would just print hello world. As simple as that. This is the most basic most basic steps to create a program and run it.
There's something I need to add. Arpan, can you just show them how can we do this thing in just one step? For example, let's show them the power of operators and all stuff.
Okay. No. So yeah, if you want to compile and just print the output in one line, you would just join the two commands that we have earlier used on different lines with just the operators. So there are some operators that are available. These are logical operators, as you may have been familiar with during your course. So we can say G++ hello.cpp, that is compile the hello.cpp file. You would say and to join two commands, and would say ./a.out. You see, it compiles the file. As soon as it's done compiling, it executes the next command that is provided by after the and operator. So this comes pretty handy when you are using Vim in Linux.
Yes, and in fact, this command, this and is often used in even in fact the Linux kernel itself to chain those commands. This is called as command chaining. We just
Yeah.
combine commands one after another. Yes,
Yeah.
so we can proceed. Take us to the slides, gentlemen. Relax and hydrate. The next coming things are challenges, and that will be done by you. Of course, we will help after a few seconds if it is difficult for you. And take a breath. Take a. Mihir Dubey says AC program in CP file. I think I can't get it. What you're saying? Can you please type it again a bit more elaborative, Mr. Mihir Dubey, please?
I guess you asked the question about difference in previous slide. He's saying about that.
Okay. AC according AC program and CV file C program. Yeah. It was exactly the mistake. Actually, it still works because CVP and C. Yes, you can see.
Yeah. Actually,
CVP.
CPP has backwards compatibility to C. So you can completely write a C code in a CPP file and it would just run perfectly fine. But if you try to write a CPP code in C, then it would just throw away errors because C is not forward compatible with C++.
Yes. And in fact, if you are a competitive programmer, you might already be aware of this fact because we generally do this, that when you want to format strings, instead of formatting separately and going for it, we use the C printf instead of Cout because it is more easy to format data in it. Okay,
Yeah.
so enough break for us. Are there any questions so far? Because after this, I guess there will be so many questions. This is the last moment with few questions. Okay, so let's proceed with the challenges. Bring it on. Yeah. It's time to play with Linux.
So I hope you all have the IDE open in a tab beside you. So you can just watch what the challenge is and try to do it on the IDE.
First of all, please let us know in the comments. Drop a yes or no if you have the terminal opened. Because of course, it's a challenge.
If there is any issue with opening the terminal.
It has to be done by you, and if there is an issue, we have to solve it right away in as quick as possible. Please drop a yes if you have a terminal open at hand to do this challenge, perform this challenge. Okay, 3 yeses. More. We have 39 participants.
Okay, is anyone having a problem opening the terminal?
Okay, another 2 yeses.
I think everyone has the terminal open.
I can hope yes, cool. Okay,
yeah.
This one. Can you tell once again file long listing? I'm getting what it is. Can you tell us once again file long listing? What are you talking about?
Do you mean the complete detailed list view of a file?
Yeah,
Rishita?
That must be it.
You can unmute if you want.
Yeah, sure. Please unmute. We are open to things. Of course, it's a workshop kind of.
LSAL, yeah. She means exactly that.
Let's do one thing. Just go show them ID and
yeah.
Show them how it works.
So basically, if you just look at man ls, so we have looked at the man command, that is a manual. So if you look at man ls, you see there is this kind of manual opens up. So there is a name ls list directory contents. Then there is synopsis that tells us what kind of syntax the ls command follows. So we will type ls, that is the command name, the option, the file. So you can see all the kind of flags here. So if it just scrolls down a bit slow. Okay, so here you see there is this -a command. So this tells the ls command, do not ignore entries starting with dot. So in Linux, if you want to hide a file, like in Windows, you right click on a file and then go to properties and select hidden. So if you want to do that in Linux, you just prepend the file name with a dot. So any files that start with a dot are all hidden by default. So what the normal ls command does, it just shows the files that are normally visible to a user. But if you want to show all the files that are also hidden, we use the -a flag. Then this is the -l format. That is the user long listing format. So long listing format just tells us about the various details of the file, that when it was last modified, who is the owner of that file, which group is the owner of that file, then if it is a directory, what kind of permissions it have. It gives us all that info. So if we quit the man and say lsal, so you can see these are the long listing format. So basically, I would just run through the format again. If you look at the hello.cpp, this here specifies what kind of permissions the files have. So we have looked at that the first three are user, the next three are for groups, and the next three is for any other people apart from user and the group. So we see that there is only read and write permission to the current user for this file. And you see this DDD in front of React parent test. This shows that it is a directory and not a file. Then this here is the username, the owner of the file, and this is the owner group. We would not get into groups and owners as much because it's quite a big topic if we want to cover. Then these are the dates on which it was modified, the time, I think it's the UTC time, and this is the file name. So this is the basic format of the long listing format of NS.
Also, you should notice that the a.out file have RWX, that is, it is readable, writable, and executable as well.
Yes. Is it clear?
So I guess we have terminals open and doubt is clear. Yes. Mission success.
So,
yes.
Let's get to the challenges.
Let's move on to the challenges. Yeah. Over to you.
So the first challenge is you have to, okay, we have not yet covered the git command. It is like out of scope of the basic Linux introduction session, but you have to just copy this command. We will post in the chat box and run it in the IDE. And then you have to perform these steps.
One little thing, if you are interested in learning about Git and GitHub, just drop a message in the post-session feedback forms that there should be another session on it, and we will cover that as well. But for now, we are not going to touch it.
Yeah. So Anmol, please drop that link into the chat box. So what you have to do is basically after you run the git command that is posted in the chat box, you have to find and navigate to the React client directory. So this is somewhere inside the folder that will be cloned by Git. So when you execute this command, there will be a React folder created on your system. You have to find where the React client is. You have to go into the directory. Then you have to ls and find the src directory and go into it. Then you have to print the current directory path, and then using relative paths. So as I have said to you, that dot represents the current directory, double dot represents the parent directory. So I can just show a simple example to not scare you off of this assignment. So if we go into like the parent child, if we let's go to the child 2. Okay, now we want to go to the child 3 directory. So we cannot just cd child 3 because there is no such thing as child 3 in child 2. Okay, it's outside of child 2. So what we'll say is cd .. slash. That .. means we are moving up a directory, that we are moving to the parent of the current directory, that is child 2. So the parent of current directory is parent. Actually, the name is also parent. And then we would say child 3. And now it brings us to the child 3, right? So if we are inside one more directory like subchild, Now we want to go into child one. So instead of just one dot dot slash, you may just put two dot dot slash because you want to go 2 levels up. So it says cd dot dot slash, that is 1 level up, one more dot dot slash, that again 1 level up, and then child one. See, it brings us to child one. So that is called the relative paths in Linux. You can just use this to navigate to different directories. So during this assignment, you have to use relative paths when you are moving from React client to React server. So you can just start doing this and ask questions if you're.
Yes, a small announcement for the participants. If you participate in these challenges via completing the task in your command line, just copy the commands you have used and the output and mail it to us. Within a week, we will provide you the certificate of participation of this event. Yes, you may continue, sir.
Yeah. So if you really want to learn Linux, please just don't go to Google and Google what is the command to change this and that. You can simply ask us if you don't understand how to do that, but just don't cheat with yourself. So try to perform this challenge genuinely.
Remember, this is a hands-on session, and the main motive is to get you get familiar and experience yourself how Git CLI works. If you copy paste it, it will work. But what are you learning in that? Of course, there will be no sense in copying pasting because it will work. You will get the certificate, but you won't be able to justify the skills and neither be able to use the so much power of Linux. Anyways, please drop us a yes.
Yeah. I
Yes,
would just like to give a small hint. If you are unable to find the React client directory, it's inside the packages directory that is just inside the React one. So when you cd to the React, there will be a packages directory. You can cd into that and you will find the React client. So that's a simple hint.
And of course, if you want to see the directories, you can use the commands that you learned. Hint ls. We will wait for like 2 minutes. 2 minutes will be fine.
Yeah, I think so.
Actually, the file is large. It's over 100 MB.
Actually, the CS50 ID is connected over cloud, so it won't take so much time. It happens in fraction of seconds if you use the ID.
Okay. Yes. In ID.
Yeah.
I was using in my terminal.
Yeah, if you use in CS50 ID, it
That's
will
why we
happen quite
please
fast.
use the ID. Yeah. The cloud systems are connected to high-speed internet connections, and it just works so well, so quick. That is the reason if you have ever used Google Colab, you will also see that your dataset download is so much fast over there because it's using the cloud internet connection and not your local one. Okay, so I have an idea for the 2-minute thing. Urban, can you please open a new tab and enter 2-minute timer? Google has a feature for it, so we can add a timer before moving on.
Okay.
Share the timer so that we can know.
Does it require kind of extension or something?
No. It's a pure open Google search thing.
Okay. It won't let me edit the timer.
Okay.
Okay.
That was not expected.
Okay, that's. Yeah.
Yeah, cool. Let's wait for 2 minutes. Meanwhile, if you have any question, okay, we have a question. Can you please explain once again the challenge part? Amir says, Mr. Amir.
Okay. So,
okay.
Just a second.
Okay. Meanwhile, keep the timer going on. We cannot take it like so much, but yeah, we can explain.
Yeah, I would share the challenge.
Yes. Arpan? Looks like we lost his voice again. Just wait for a while. Okay, Arpan, are you there? Okay, meanwhile, let me explain it. So first step, clone React by, this is just a simple command that clones the repo from the remote place to your own system or your file system, you can say. The next thing is navigate to find and navigate the React client directory. As said, it is a directory, not a file. So there will be a bunch of files inside it, folders inside it. How will you do it? Because we just learned there is this thing called as ls commands. You can list what are the files and folders in the current directory. You will find you will see where to go. As Arpan already said, there is something called as packages. Inside the package folder there is this React client, and there is a shorter way to do this. We'll show that in you just a few seconds. Arpan, are you back?
Yeah, I think there was a net issue.
Yeah. See, is the timer still there?
15 seconds.
Amir asks, what is the aim of this challenge? Okay, so for example, you are working on a project. We all work. We all are engineers. We work on some or the other projects, and there are times when you are what file you contributed in case of some big projects, and if you're contributing to open source, and even in case of simple softwares, there are moments when you know the file name but you don't know where it is, or specifically when it's inside a couple of bunch of folders. The challenge is to get you familiar with how can you use ls and all those commands to get things done what you want. For example, if you go for Windows, you open the folders, you scroll down here and there, and you have to open each and every folder. But in case of ls, you don't need to even scroll, because ls gives only the file name, that is text, and you can list lots of folders and file names in just one screen. You don't need to scroll. You are saving a lot of time of yours. And the second step comes up when you look for, we will show you a command to find these things and all stuff without even actually going into a directory. You can see is the file inside it or not. We will show that. And this is what comes handy when you are on a crucial project and you have so much less time to work on it, or you can say you need to get things fast. Linux is productivity beast, you can say. If you really use it, and you will realize that so many ways it helps you. And in a nutshell, if I want to say that what is the difference between the speed of a Windows user and a Linux user, I will say for whenever this user is interacting with the OS directly, there is going to be a 3 times shortage of time to get things done, the same amount of work in case of Linux, in comparison of Linux, you can say.
Yeah, actually the timer is up, so we would just demonstrate this first challenge.
Yeah.
If you are not able to
Yes.
do it, so just watch carefully.
Yeah.
So you will have this kind of a terminal, and there would be a React folder. If you have cloned, there will be such a React folder. What you can do to go into that React folder, we have studied the command cd. So it's a cd React. So we are into the React folder. Now we want to look at what kind of files and folders are here. So we just say ls, and these are the different kinds of files and folders. So I gave you the hint that there is a packages kind of directory. So we would just say cd packages. Packages. So we are into the packages. Now you just say ls to see what are the contents of these directories. So it contains quite a lot of folders or directories. So now you can see here that there is a React client. Yes. So you can just say cd React client. You are into the React client. Now you can just ls. Now you can see that there is some files and some folders. So the aim of challenge was to go into the src directory. So you just say cd src. Now we are into the target directory. That was the first part of the challenge. The next part was to print the current working directory. So it would say pwd, and it prints the complete path, not the relative path. It prints the complete part of that file. Now we want to go to the React server src. It is similar to the React client, just it's a different name. So to go back, we would just say cd ... It would bring us from src to React client, but we want to go into the packages folder because the React server is in the packages. So we would say again // we want to go 2 level up. So we are into packages. Now we would again list it, and here we would say there is a React server file, server folder. Sorry. So it says cd React server, and we would again ls, and we can see there is a src folder that we wanted to go into. So it says cd src.
Okay,
That was the
now one more
challenge.
thing. Yes, one thing we didn't told you earlier. There is something called as tab with auto completion on tab.
Yeah,
You don't need to specify the whole name if there is no file name conflict, that similar file names are not there and there are unique file names. You can just type 2 or 3 characters and press tab, and it will auto complete the whole file name for you.
yeah, similar to if you have used an IDE, you can just type in a few characters and it would complete the command on tab, just like that.
Perfectly.
So
Okay,
if
so
you, I would just want to show a small, like a shorter version of this. So just clear the screen. Now we wanted to
this is
find
the fun
the,
part.
yes, one more.
This is the fun part now because there
Yeah,
is a shorter way in Linux.
yeah. So we can actually use the find command. We didn't cover it in depth, but if you kind of explore the find command with man, so there is a option that is find. We can specify the name. So we would say React client, and we would specify the type, whether it is a file or whether it is a directory. So we'd say type D. Type D stands for, it specifies the type, and D stands for directory. So it just shows us the React client whole path. So we can just copy that path. We can say cd that, don't forget the dot, and we can go to that. We can ls, we can go to cd src, right? So we can just again use the find, the same command that we used, and we can specify the root path from where you want to search. So we would just specify tilde, that is the home location of the terminal. So I didn't change the, we want to search for React server. Yeah, so it gives us the complete path of React server. So you just copy that, cd. Now if you want to do that relatively, you can just go /// 2 levels up. You can say React, then hit just S, and if you double tap, it would just show all the files that start with React and S. So there are server, DOM relay, and everything like that. You want the server, and you can just hit that cdsrc, and you're done. So you can use
Yes,
find
so
to just find the files and directories in a large project structure.
yes, so I think this makes it clear that what was the aim of this challenge. The challenge was itself simple. We wanted to show what is the power of other utilities in Linux. So
Yes.
let's proceed on to the next challenges. We are getting a bit short of times, but so let's
Yeah.
cover it a bit quicker.
So this is the challenge 2. Basically, you have to create this kind of a structure. You already saw this kind of structure. I just while I was demonstrating. So you have to create this kind of structure in your IDE, but you have to use the mkdir command in one line. That is, you cannot do mkdir parent, then go into that using cd, then mkdir child1, mkdir child2. Not like that. You have to create this structure in just one line of mkdir. And I've demonstrated that too. So if you remember correctly, try it out. Then you have to make all these directories and then copy, move. You have seen all these commands, cp, mv. So try it out. I would just start the timer. These challenges are just focused to make you comfortable, or I would say aware of how the terminal works and how all these commands work.
Please share the screen of timer. I think that
I think
you can let it be. The challenge should be visible all time.
yeah, that's fine. Thirty seconds.
Okay.
Okay, so we would just quickly demonstrate how this challenge could have been done. If you're not able to do, just watch carefully. So I would just delete the original parent directory. Yeah. So now we wanted to create this kind of a structure. So what we can do is we can say mkdir, then we would specify -p, that stands for create all the parents. Then the parent directory's name, that is parent. Then a slash, because we want to create all the directories inside of this directory. So slash and curly braces. Now we want to create child 1, child 2, child 3, and child 4 as the children of parent. So we'd say child 1, child 2, child 3, child 4. These are all the children of parent. Now we want to make the sub-children of child 2 and child 3. For that, we would just go to child 2, say a slash, because we want to make some children of child 2, again curly braces, and then subchild 1 and subchild 2. So subchild 1, subchild 2. Okay, so now the child 2 is done. Now similar inside child 3, so it give it a slash, then curly braces, and would say subchild 3 and subchild 4. Subchild 3, subchild 4. And that's it. This is the command to create that structure. So now if we tree the parent, and there you have it, the structure that we wanted. So this was the basic command to make the structure. Now next is like the copy and move thing. So we would just make an empty file inside. What you have to do, we have to make an empty file inside child 1 and subchild 2, copy the subchild 2 file to child 3 with a different name, then move the file in subchild 2 to subchild 4 and remove the child 2 directory. So we would just touch a file, touch child 1, okay, cd parent, touch child 1.
Arpan, just one thing.
Yeah.
We are watching the slides.
Yes. Terminal is not visible.
Oh, sorry. My bad. Touch child 1, and like if I would say file 1 dot text. Okay, so it just creates file 1 dot text in child 1, and one more file in subchild 2. Okay, So it's child2 touch child2 subchild2 and file2.txt, let's say. So it has created a file2.txt in the subchild2. Now we want to copy the file in subchild2 to child3 with a different name. So it would say cp. Then we want to copy this file child2 subchild2 and file.txt to a different location, that is child3, right? It's child3 and with a different name. So it just rename, give a different name to the file, that is file3.txt. So if we ls child3, see, you have got a file3.txt file. It is a copy of the file2.txt. Okay. So now we have to move the file in subchild2 to subchild4. So you just use the mv command, that is move. We can just modify this only, mv child to this file to subchild4. So child4, no, it's subchild3. Okay, child3 subchild4, and we'll give it a new name, that is file4.txt. So if we ls child3 subchild4, you would see file4.txt. But now if we ls the original file2.txt, we would not find it because it has been moved. Moved means it has been deleted from that place and moved to the current directory, that subchild4 directory. So if we say ls child2 / subchild2, it's empty because the file has been moved. And the last thing is we have to remove the child2 directory. So we would just say rm a -r flag because it is a directory, so we have to be recursive, and would say child2, and we can say yes. Okay, so to not get this yes or no prompt every time, you could just say rf. That will forcefully delete all the files without requiring explicit permission. So now if we ls, child2 is gone. So that was a simple challenge playing with files. So let's move on to the next challenge. It is challenge 3. Yeah, so this is the challenge. So first of all, the React directory that you have cloned earlier, you have to go into that. There is a readme.md file. You have to find the word Taylor in that readme.md file using the command that we have studied. Then you have to save the output of the above command into a file called taylor.txt using piping and redirection. We have also seen how to save some output of a command to a file. And then we have to append this file, that taylor.txt, with a line called this thing, the lines found. That's it. Simple challenge. The timer has been started.
How many challenges total we have?
Just one more after this. Only 4
Okay.
challenges.
We are little bit running late on time.
Yeah. If the people are not okay with extending the session to this much, we can just skip the next challenge if they want.
Yes, it's all up to you. It was actually difficult for us to give up on things and move forward without telling the behind things.
Yeah.
If this is just
you can just perform that challenge once you get the PPT and material.
Yeah, for sure.
Yes, we
And this
will,
is just a droplet of Linux, not the whole Linux yet.
Yeah.
yes, we will share the slides when they will complete the challenges.
Yeah,
Yeah.
If someone was not able to do it simultaneously, then later he or she can do.
for sure,
Yeah.
for sure.
Hello.
30 seconds.
Just yes, yes.
We want to
Yes,
submit
Amir.
assignment after lecture.
What?
Pardon?
Can we submit the assignment after the lecture?
Yes, you can submit
Yeah,
it
yeah,
by today.
sure.
Yeah, for sure.
How much duration you have?
Rona can say on that.
Regarding
Mr.
session's duration,
No, he's asking for how by what
Huh?
time he can submit the assignment, or you can say the task progress to earn the certificate.
please submit it by today only before 12 p.m.
Okay,
Yeah,
this three challenge, no?
Yeah, we will
yeah,
just cover the 3 challenges
Yes,
because of the time. You can also submit the challenge for if like the PPT is shared by today, you can perform it and submit it.
yeah. We can share the PPT by today, right, Mr. Ronak?
Yes, we will be sharing it by evening to the participants.
Yeah,
Sure.
for sure. You can just refer the PPT, perform the challenges, and submit it. Just we do it before midnight. Okay.
Yeah. So time's up. We will just demonstrate the challenge quickly and move on.
Yeah, we can. I think it's better we don't cover the full challenge for
Yeah,
now.
because it will be time consuming.
Okay.
Okay.
Go ahead.
So we have to go to the React directory. So let's do that. CD React. Then we have to go to the file readme.md. So just ls find where is the readme.md file. So this is the readme.md file. Okay. So what we have to do is we have to find the word Taylor in readme.md. So we would just say we have studied grep. So we would say grep find this string Taylor in the file readme.md. And there you have it. It finds the lines that contains the word Taylor in readme.md. The next challenge was to save the output of the above file, above command in a file called tailor.txt. So we can do this and then we can use redirection as we have seen. So we want to create a new file and save the output in it. So you'd say tailor.txt. So tailor.txt is created. If we just ls there is a tailor.txt. If we just cat it out, we want to see the contents. See, the same thing that the grep outputted earlier was saved to the file. Now we want to append lines found, this line here, to the file. So you just say echo lines found, and to append there are double greater than signs. Append to tailor.txt. And if we again cat out cat tailor.txt, so you see lines found, and that was a challenge. So let's move on. Skip the challenge 4. So these are some like screenshots of the main thing about Linux is customization. Windows does not allow any customization, whereas Linux you can customize the way you want. Everything from the desktop to the taskbar to the search bar to the applications, everything can be customized. So that is the power of Linux. This is my current desktop actually. So it has a Mac theme. If you love Mac OS, you can customize it the Mac way. This is about the terminal. So as you have seen the CS50 ID, some of you may have been freaked out about what's going on in the ID, but with a bit of time and patience, you can just customize the terminal to look beautiful and not spook you out. So this is an example of a ZSH, which is the like most beautiful terminal that exists.
Yes, we can cover.
These are some screenshots. This will be skipping for now.
Yes.
So the last question that arises is you have learned about Linux, you have learned about what is Linux all about, what are the commands, or what can you do with it. So the question arises, what Linux based OS should you go for? How do you decide? So this is quite a good infographic that allows you to select the OS or the distribution of your preference. So all the things that are mentioned in these rounded rectangles are the distributions. You can install any one of them based on what you reach, like what kind of position you reach in the flow graph. So there are so many distributions that you can install and so many flavors of Linux. This will be all, you will get the PPT, so you can just tinker with it. And these are some awesome resources to get you started. So you can just explore all these resources once you get the PPT. And thanks for being here. Thanks for making the session possible.